Assalamualaikum and hello everyone. My name is Safi Fadlin and today our Group 1 from CS1103A, will be doing a presentation for the group database project. There are 4 members in our group. The first member is Ashraf Iqbal Aizuddin bin Daud. The second member is Muhammad Hanif Afif bin Hamran. The third member is Hazwan bin Haizaini Muhammad. And the last member is me, Hafiz Fadlin bin Normain. There are 5 main contents in our project, which are Introduction to Organization, Problem Statement, Database Component, SQL Command Component, and References. Moving on, Introduction to Organization. Malaysia Airlines is the national carrier of Malaysia, offering the best way to fly to, from and around Malaysia. Malaysia Airlines carries up to 40,000 guests daily on memorable journeys inspired by Malaysia's diverse richness. Malaysia Airlines embodies the incredible diversity of Malaysia, capturing its rich traditions, cultures, and cuisines via its inimitable Malaysian hospitality across all customer touchpoints. Since September 2015, the airline has been owned and operated by Malaysia Airlines Berhad. It is part of the Malaysia Aviation Group, MAG, a global aviation organization that comprises different aviation business portfolios aimed at serving Malaysian air travel needs. As a member of the One World Alliance, Malaysia Airlines offers superior connectivity with seamless journey to as many as 1,000 destinations to more than 170 territories and access to over 650 airport lounges worldwide. As the pandemic strikes the nation and the world, this situation makes it an even worse and tough time for everyone, especially for Malaysia Airlines. Most of its department and the employees were forced to be reduced, and their salaries also slightly reduced too, and thus making this more challenging to handle all of the crucial data for Malaysia Airlines department. The organization was then required to have a new system to store the important data and could also reduce the spread of the COVID-19 virus through paper distribution. Malaysia Airlines has decided on a database based on SQL, in which the system would be called HaHaHaraf Management System, in which it would store the information of the airplane, passenger, pilot, flight, and ticket. Next, we have the organizational chart for Malaysia Airlines. Moving on, we have the current system description. The system that Malaysia Airlines currently uses is papers and documents to store the important data of the company. It is still using offline documents in organizing the company, and most of the documents are stored and kept inside a list. This could be troublesome since some of the details are not to be found and missing. Sometimes, most passengers need to wait longer to book the flight physically due to there being no database. And next, I will pass to Hazwan to continue with the presentation.
Thank you, Hafi. So I'm going to start my presentation for the problem statement. So it is basically hard to buy a ticket because of the pandemic that is still going on throughout the world. With COVID-19 that's still lingering in the air, it is still not safe to buy the ticket because it can easily infect other people. Without the proper discipline at the airport, it might easily cause huge problems to the staff and citizens during payment of the ticket without proper control of the situation. If some people got infected and did not take quarantine while still buying the ticket, that can make the situation even more worse. Next, the server for bringing tickets through the apps is always down due to the heavy traffic. The users always have difficulty booking tickets online. In addition, document management for aviation requires a lot of space to keep in the locker. It's very hard if the management of the locker is full and space for the other new files that keep coming might not have space to keep it safe, or the situation that the staff didn't want to happen if they didn't take the early measurement to evade the problem. So for next one, for the proposed database objective. The objective of our system is to provide an efficient and practical database to be used by the company. Therefore, the company can focus on handling a high amount of booking without getting the risk of losing data. Other than that, the ticket database system was designed to help customers to buy tickets online. Hence, it will reduce the risk of getting infected with COVID-19 and thus lessen the hassle of needing to buy a ticket physically. Furthermore, the system will also secure the safety of our plane ticket. Therefore, passengers do not have to worry about getting their personal information leaked and used by other people. And that's all from me. So I'm gonna pass the next one to Hanif. Thank you.
Next is business rules. From the problem statement, we can identify our business rules, which are one passenger can buy many tickets. Each ticket can be bought by one passenger. This is one-to-many relationship. Next, one flight can have many passengers. Each passenger can have many flights. This is many-to-many relationship. Next, one flight can be fly by many pilots. Each pilot can fly one flight. This is one-to-many relationship. Next, one airplane can fit many passengers. Each passenger only can fit in one airplane. This is one-to-many relationship. Lastly is one airplane can have many flights. Each flight can have one airplanes. This is one-to-many relationship. Next is database component. This is our ERD. From the ERD, we can see that we have pilot, flight, boarding pass, passenger, airplanes, and tickets. Pilot and flight is linked by many to one. Next, flight and boarding pass is linked with one to many. Boarding pass and passenger is linked with many to one. Passenger and ticket is linked with one to many. Lastly is flight and airplane is linked with many to one. Next is data dictionary. From the ERD, we can explain it to data dictionary. It is easier to understand. Firstly is passenger. In passenger, we have attributes, passenger ID, passenger first name, passenger last name, passenger email, passenger contact number, and the PK for passenger is passenger ID. Next is tickets. Tickets attributes is ticket number, ticket invoice number, ticket destination from, ticket destination to, and passenger ID. For the PK in ticket is ticket number, and for the foreign key that we take from passenger is passenger ID. Next, airplane. The attributes in airplane is airplane ID, airplane manufacturer, and airplane model number. For the PK in the airplane is airplane ID. Next, flight. Attributes in flight is flight number, flight departure date, flight departure time, flight arrival time, and airplane ID. For the PK in flight is flight number. And for the foreign key that we check from airplane is airplane ID. Next is boarding pass. Attributes for boarding pass is passenger ID, flight number, and seat number. And the PK for boarding pass is we have two, which are passenger ID that we check from passenger and flight number that we check from flight. Lastly is pilot. We have pilot ID, pilot first name, pilot last name, pilot contact number, and flight number. For the PK in pilot, we have pilot ID and the foreign key that we check from flight, which is flight number. For the database component, I will pass to Ashraf to explain it more specifically. Thank you.
Hi, I am Ashraf. So I will continue for the next presentation. So for the next presentation is about the database component. So for the database component, the first command we use is create database. So we create database passenger, then use passenger. And then the next one is create tables. So there are several tables have we created. So as you can see, the first table we create is create table for the passenger. And then the next one is create table for the tickets, create table for the airplane, create table for the flight, boarding pass, and then the last one is create table for the pilot. And then next one is adding row in the tables. So we use the insert command to insert the value inside the table that have we created. So we insert the value into the passenger tables, ticket tables, airplane tables, boarding pass tables, flight tables, and then the last one is pilot tables. So these are the value that we insert. So the value we insert, there are 10, I think, for the all these tables. And then SQL command component. So let's begin to the select statement from all table. So we select from passenger table, and then it show the output of the table. So for the output of table, there are 10 record for the passenger, same like tickets, and then airplane, boarding pass, then pilot. Last one is flight. So these are the output, and then all of them have 10 records. Hi. So let's begin to the retrieve data from multiple table. So the first command select passenger first name, passenger last name, seat number from passenger in join boarding pass, where passenger ID equal to boarding pass passenger ID ordered by seat number. So from the output, we can see the table show the passenger first name, passenger last name, seat number, and then this table is ordered by seat number. So for the second one is the command is select from passenger pilot, cross join passenger flight. So from this table, we can see the table from the pilot and then the table from the flight are combined. That's why there are many tables show there. And then the third one is set passenger first name, ticket number from passenger, passenger, join passenger ticket, where passenger ID equal to ticket passenger ID. So from this table, we can see passenger first name and then the ticket numbers. The fourth one is we select airplane ID, pilot ID from flight, join flight, where flight flight number equal to pilot number, and then there are the condition where the pilot ID must 0222. So from this table we can see the airplane ID and then the pilot ID. So the pilot ID is 0222 from this table, same like the command we create. And then the last one is we select pilot first name, flight departure time from pilot, where initial flight, where flight number equal to pilot flight number. And then there are condition where flight departure time must equal to 9 March 2022. So from this table, we can see the flight departure date equal to 9 March 2022. So there are two, which is Joseph and Angus for the pilot name. So let's move to the SQL function. So for the SQL function, we select flight number, flight departure time from flight where flight departure time must larger than 10 o'clock. So from this table, we can see the flight departure time is larger than 10 o'clock. The second one is we create the password. So this is the password based on the condition where concat passenger ID upper substring passenger name 1 2. So this is the user password. And then the third one we can see is select flight number, select flight departure time, flight arrival time, and then the flight departure date as a promo month where the month is in September. So the month in September will be as promo month. So there are two. And then the last one is using subsquery. So the first subsquery command is select insert flight number, airplane manufacturer from flight nitrogen airplanes, where airplane manufacturer likes air. So we can see from these tables, airplane manufacturer is Airbus, same like the command we use, which is air, like air. And then the second one is we select passenger first name, last name, passenger email address. Where exists select passenger ID from ticket. So this is the table. We can see the table from the second command. It show passenger first name, last name, and email address. And then the third one is we select distinct passenger first name, ticket destination, national tickets where ticket destination like Kuching, ordered by passenger first name. So from this table we can see the ticket destination is to Kuching. So there are 1, 2, 3, 4, 5, 6. 6 ticket destination to the Kuching. And then this is the reference we get for the whole group project. So there are 2 reference. And then I think on it from our presentation, I would like to say thank you for stay tuned from the beginning until at the end. So on it from us, thank you.